Well, hey everybody, it's Mr. Kingsbury. I just wanted to record the examples that I did in class, just in case that they went by too quickly for you to be able to write them down. So they're all substitution. There are 5 of them. Let me start with the simplest. Example 1. Here are the systems. We have x equals -3 and y equals x plus 7. This is by far the simplest system ever. And the reason for that is we already know what x is. X is equal to -3. So all I have to do is replace the x in the other equation with a -3 and then solve. So -3 plus 7 is 4. So I get y is 4. So my solution here is xy equals -3, 4. So that's pretty easy, I think. Should be pretty straight up. I have another one similar to that, only it has 3 equations that I would like to show you. So here's example 2. Here's the system. We have, let's do this. Let's do, is it 6? Do I want to do 6? I meant 2. 2z equals 6. We're going to do 4x plus 4z equals 8. And then the last equation will be -x minus 5y minus 5z equals -24. One of the best things you can do for yourself is figure out how many variables are in each equation. This one has 1, this one has 2, this one has 3. If you have an equation that has 1 variable, that equation is solvable. So this first one, 2z equals 6, I can solve that. Simply divide both sides by 2. 6 divided by 2 is 3. So on the right, I have 3. On the left, 2 divided by 2 is 1. And 1 times z is z. So I know that z equals 3. Now, once you have the value of one of the variables, you want to start plugging that into the other equations. And the best way to decide which one to plug it into next is to go with the one that has the next fewest variables. In this case, we have one that has 2 variables and one that has 3 variables. Let's go with the one that has 2 variables. So that would be 4x plus 4z equals 8. And we now know that z equals 3. So I can remove this z and replace it with a 3. From here, you're going to want to simplify first. Usually the fastest way to get to the answer is to simplify and then solve. And simplifying means multiplying stuff, either distribute or multiply things that you can, and then collect like terms. In this case, we can certainly multiply 4 and 3. We get 12. So this becomes 4x plus 12 equals 8. And then from here, there's no like terms. There's nothing else to multiply or distribute. So we can start solving. Now, I'm looking at this. I see 1 term that has a variable, 2 terms that do not. I also see that the right side has 1 term and the left side has 2. Now, if I remember my process correctly, I need to get my equation to a point where there is 1 term on either side of the equal sign. Then I can determine if I need to divide or not. So right now I have 2 terms on this left side, which means I need to get rid of one of them. And whichever one I cancel out, I get rid of, it better be able to merge, to combine with 8. And things only combine if they are like terms. Well, 8 does not have a variable, which means any terms that don't have a variable, we will be able to combine with 8. So on the left side, one of these 2 terms does not have a variable, which means it will be mergeable with 8. That would be 12. So I need to cancel the positive 12. And I will do that by subtracting 12 from both sides. Now, on the right side, 8 minus 12 is negative 4. On the left side, 12 minus 12 is 0. 4x plus 0 is 4x. So I now have 4 times x equals negative 4. Usually when I get in this situation, what I want to do is divide by whatever the coefficient of x is. That'll undo the multiplication. And what you do to one side, you must do to the other. So I will divide both sides by 4. On the right, negative 4 divided by 4 is negative 1. On the left, 4 divided by 4 is positive 1 times x is x. So I now know that x is negative 1. So look, I've got my z value is 3. My x value is negative 1. So now I can replace, or I can substitute into this final equation. So that's what I'll do. And I'm going to write it over here. I've got negative x. My x is negative 1. So negative, negative 1. This negative is different from this negative. They're different. So they both need to be in here. Minus 5 times y, minus 5 times z, but my z is 3. And that equals negative 24. And once again, I will simplify. Negative negative 1 is positive 1. Then we've got minus 5y. And negative 5 times 3 is negative 15, which equals negative 24. There's a negative here. I did not do a good job of writing it in clearly. And then lastly, I'm going to combine like terms. 1 and negative 15 combine to give me negative 14. So my new equation is negative 5y minus 14 equals negative 24. And from here, I can solve. Now I'm going to do much like I did over here, and I'm going to cancel the constant. I'm going to add 14 to both sides. And I chose 14 because it does not have an x, just like negative 24 does not have an x. So I know those two will be able to combine, right? Negative 24 plus 14 is negative 10. Negative 14 plus negative 14 is 0. And negative 5y minus 0 is negative 5y. So I now have negative 5 times y equals negative 10. To undo multiplication, I will divide. And what you do to one side, you do to the other. Typically, when I divide both sides by something, it needs to be the coefficient of the variable, which is negative 5. So I will put that on the bottom here and here. On the right, negative 10 divided by negative 5 is 2. That's a 2. Does not look like a very good 2. On the left, negative 5 divided by negative 5 is positive 1. 1 times y is y. So I now know that y is 2. So I can write out my solution. X, y, z equals negative 1, 2, and 3. There we go. All right. 2 examples down, 3 to go. So these first 2 examples were pretty great examples of what happens when you are given one of the values, or at least it's really easy to find one of the values. And the kind of quick and dirty solution or process is, since you have that first value, plug into the equation with the fewest number of variables to find the remaining variable, and then plug into the last equation as well. And you just keep plugging in values and solving until you found the value of all 3 or 4 or all of the variables, all right? The next 2 examples I want to do are examples of what you do when you haven't been given the value of a variable to begin with. So let's do example 3, and I'm probably going to end up using a little more space for this. No, that's a lie. Example 3 is pretty quick, but example 4, I'm going to need a bunch of space. So example 3 is 2 equations with 2 unknowns. I'm going to give you x equals y plus 3 and 4x plus y equals negative 13. Now you'll notice that I haven't given you a value for either x or y. So we're going to have to substitute something into something to figure out one of the variables. Now the nice thing about a system of 2 equations is you don't have to decide which 2 equations to use you know which two equations you will be substituting into each other. It just becomes a question of how do I do that? And when you have an equation like this first one that's solved for a variable, those are your directions for substitutions. They say, everywhere you see an x, replace the x with y plus 3. Well, look at this equation here. I have an x right here. So I will replace that x with y plus 3. Don't forget we're still adding a y, and it still equals negative 13. And I will distribute this 4. 4 times y is 4y. 4 times 3 is 12. We're adding y, still equals negative 13. I'm going to go ahead and combine my like terms. 4y and 1y are 5y's plus 12 equals negative 13. I will subtract 12 from both sides. On the right side, negative 13 minus 12 is negative 25. On the left side, 12 minus 12 is 0. And 5y plus 0 is 5y. So we have 5 times y equals negative 25. I will divide both sides by 5. On the right, negative 25 divided by 5 is negative 5. On the left, 5 divided by 5 is 1. 1 times y is y. So now I know that y equals negative 5. And then all I have to do is plug that into this first equation. So x will equal negative 5 plus 3, which is negative 2. So x equals negative 2, which means my solution is xy equals negative 2, comma, negative 5. There we go. I'm going to flip to the next page because I know these last two problems require a little bit of work, but now you see what to do. So with the two equations, we know we'll be substituting one of them into the other. It's just a matter of which one goes into which one. And certainly the one that's solved for a variable will tell us what to substitute and what variable to substitute it for. When we have 3 equations and 3 unknowns, it becomes a little trickier because we have to decide which 2 equations to start with and then how to substitute them in and that sort of thing. This is where knowing and identifying how many variables are in each of your equations is going to become more and more important. So our first equation here is y equals x plus 4z minus 14. The second equation is going to be 4x plus 3y minus 2z, and that's going to equal negative 9. And then the last equation is z equals negative 2x plus 2. The top equation has 3 variables. The middle equation has 3 variables. The bottom equation has 2. Now, I'm identifying that because if one of those happens to have just one variable, that tells me I can solve it. And I'm going to go ahead and solve it for that value of whatever the variable is. And then I'm going to find the equation that has the next fewest number of variables, probably 2, and I'm going to substitute into that, and I'm going to solve for the remaining variable. And then I'll continue on to the third one. If I don't have an equation with one variable in it, then I'm going to start on the other end of things, and I'm going to find the equation that has the most variables in it, and then substitute the equation with the next most number of variables into that one. This is just to make the number of steps you have to take shorter. You'll note these first 2 both have 3. So I'm going to substitute one of them into the other. And the one that's solved for y, this first one, is going to tell me how to do that. So I'm going to take 4x plus 3y minus 2z equals negative 9. And I'm going to replace the y with x plus 4z minus 14. And don't forget to subtract 2z, and it still equals negative 9. From here, then we simplify, distribute, collect like terms. So 3 times x is 3x, 3 times 4z is 12z, and 3 times negative 14 is negative 42. I'm still adding 4x in front of it and subtracting 2z's behind it, and it still equals negative 9. Now I'm going to collect my like terms. So I got 4x and 3x, and then I've got 12z's and negative 42. 12z's, my bad, and negative 2z's. And the negative 42 just is by itself. So 4x's and 3x's is 7x's. 12z's and negative 2z's is 10z's. And then we've got minus 42, and that equals negative 9. The other thing I'm going to do is try and get all of the constants on the right side. And that's just kind of a general guideline. When you're solving systems, you want to keep all of the variables on one side and all of the constants on the other. So I'm going to add 42 to both sides. Negative 9 and 42 is 33. On the left side, negative 42 plus 42 is 0, which leaves me with 7x plus 10z. So I didn't get a variable by itself like I wanted, but I do now have an equation that only has 2 variables, which is nice. That's a step in the right direction. So now what? Well, I would go back and look at my equations. I used these first 2. Let's look at the third. The third only has 2 variables. They are an x and a z, and it is solved for z. Well, hold on now. If I look at this right here, this also has an x and a z. So if I were to replace the z with negative 2x plus 2, I could solve for x. So this becomes 7x plus 10 times negative 2z plus 2. And it equals 33. I'm going to distribute my 10 here. 10 times negative 2z is negative 20z. 10 times 2 is 20. The right side is just 33 still. Oh, and don't forget there's a 7x out front. I'm sorry. I did that wrong. This is negative 2x, not negative 2z. So this should be an x, which makes this an x. And that means I can put 7x's and negative 20x's together. That gives me negative 13x's plus 20. And that equals 33. I will subtract 20 from both sides. 33 minus 20 is 13. 20 minus 20 is 0. And negative 13x plus 0 is negative 13x. And all I have to do is divide both sides by negative 13. Negative 13 divided by negative 13 is 1. 1 times x is x. 13 divided by negative 13 is negative 1. Now that seems like a lot of work, and truthfully, it is a lot of work. We had to do 2 different substitutions, but we finally got x equals negative 1. What's nice is the rest of this falls together very quickly. I can take this x and plug it in here and get z. So z is going to equal negative 2 times x. Well, x is negative 1, so this is negative 2 times negative 1 plus 2. And then I can simplify. Negative 2 times negative 1 is positive 2. So z is going to equal whatever 2 plus 2 is. I'm pretty sure that's 4. And then lastly, I can take x and z and substitute them into, well, it doesn't matter which of these 2 I substitute them in. I'm going to do the top one because it's equal to y, which means I don't have to do any solving steps. I can just evaluate. So I'm going to go y equals x, which is negative 1, plus 4 times z, z is 4, minus 14. And from here, I can just follow PEMDAS. 4 times 4 is 16. So I get y equals -1 plus 16 plus, not 6, sorry, minus 14. -1 plus 16 is 15, so y equals 15 minus 14, and 15 minus 14 is 1. So y equals 1. So now I know what z is, I know what y is, so I can write my solution. X, y, z equals -1, 1, and 4. That one was kind of a long one, I will admit, and it involved 2 different substitutions. I would note, though, that once we found the value of x, the other values came very quickly, or we were able to solve for them very quickly. All right, I've got one more example, and this is an example of when you need to solve by substitution, but what you've been given has not been set up for substitution. So our equations are x plus y plus z equals -1, 4x plus y equals 14, and 2x plus 2 equals 5. Now you'll note none of those equations has been solved for x or y or z, not a single one. So truthfully, substitution would not be my first method for solving something like this. But you will have one on the test, so it's important that we look at one so you're prepared for it. What I would say is this. We need to make at least one of these equations substitutionable, meaning we need to rearrange it so that it's solved for a variable. Now, what popped out at me when I was writing these is that both the y and the z, this is a z, both the y and the z have coefficients of 1 in these 2 equations, right? This has 3, by the way. This has 2, and this has 2 variables. Don't forget that part. Very important. Okay, so what I want to do is substitute into x plus y plus z, because that's got the most variables. But I need something to substitute in for. So I need to pick one of these and figure out a way to make it so that I can substitute something in. Well, let's start with 4x plus y equals 14. Well, the y, it has a coefficient of 1. It's by itself, if you will. So if I were to get rid of the 4x that's on the same side and y was all alone, all by itself, I could substitute whatever that expression with x is in for y. So I'm going to do that by subtracting 4x from both sides. Now on the left, 4x minus 4x is 0. 0 plus y is y. On the right, some of you are going to be like, 14 minus 4x is 10x, and you would be wrong. That's like saying if I have 14 oatmeal raisin cookies and I eat 4 chocolate chip cookies, then I have 10 oatmeal raisin cookies. Can you see how it doesn't make sense? Because you didn't eat oatmeal raisin cookies. You ate chocolate chip cookies. It doesn't make sense. It's weird. It's different. So instead, we're just going to write 14 minus 4x. And I'm going to do the same thing with the other one. Since it has a single variable there, I'm going to take 2x plus z equals 5, and I'm going to solve for the z by subtracting 2x. Cool. Once again, on the left, 2x minus 2x is 0. 0 plus z is z. On the right side, we've got 5 minus 2x. Again, it is not 3x. You can't do that. You just rewrite it. 5 minus 2x. Now, what's great about this is both of them have an x. So when I substitute in, what I'll be left with is just x's. So let's do that substitution. So we've got x plus y, but we know y equals 14 minus 4x. Plus z But again, we're going to replace z with something with an x, 5 minus 2x. And that still equals negative 1. And what I can do then is combine my like terms. So x, negative 4x, and negative 2x. If I put those together, let's see. X plus negative 4x is negative 3x. And I take negative 3x and subtract 2 more x's, I get negative 5x. And then I can put 14 and 5 together, and I get 19. I will subtract 19 from both sides. On the right side, negative 1 minus 19 is negative 20. On the left side, 19 minus 19 is 0. Negative 5x plus 0 is negative 5x. And we'll divide both sides by negative 5. On the right side, negative 20 divided by negative 5 is 4. On the left side, negative 5 divided by negative 5 is 1. 1 times x is x. So I now know that x equals 4, which is great. I can now plug that x into these two equations up here. Let's start with this one. Y is going to equal 14 minus 4 times 5. 4 times 5 is 20. I'm sorry, negative 4 times 5 is negative 20. 14 minus 20 is... I did that wrong. This is 4 times 4, which should be 16. 14 minus 16 is negative 2. Happens to the best of us. Then we'll do the same thing with z, right? We've got z equals 5 minus 2 times x. Well, x is now 4. So I can multiply 2 and 4 and get 8. So I get 5 minus 8, which is negative 3. So my solution is x, y, z equals 4, negative 2, negative 3. And those are some examples for you. Just wanted to give you the ability to write them down, go through them, look at them, etc. Appreciate your time. Have a great day.